Hello, so we're going to do some Trig problems. Let's see, we'll start with here. Okay, this guy. Now all right, so what you'll see here is it says sine of 2 theta. So this is talking about a double angle. So we don't know what theta is. We don't need to know, just the information given here. So regardless of how much I prepare, these things are always choppy. All right, so we want to start with this guy first and find out where that is. And I'm going to make a either triangle or something with the unit circle. So let's say if I start with the unit circle, where would this triangle be? Okay, so you got sine being negative. Now remember this the positive negative signs here, so that everything's positive over here, only sine and cosecant here, only tangent and cotangent, and then the last one is cosine and secant. So if you have a negative sign, it's in one of these two places. Okay, can't be here, can't be here. Those are positive. It's got to be down here or here. So then we look at this extra information. It says from pi to 3 pi over 2. So that means like from 180 to 270. So here is pi, 3 pi over 2. So this one is in the third quadrant. Once you know the quadrant, you draw like a little picture. Don't worry too much about the scale or anything. So let's start something like that. And I think about the scale because it just bothers me if it's off by too much. So where your angle is always going to be touching the x-axis. Okay, so it's never going to be like this one. And then we have -7, that's over here. I can put the sign with it, so it's just saying it's going down. And over the hypotenuse, which is 25. Now, before going any further, we want to do is figure out this side right here. And if you know two sides of a right triangle and you want to find the third, you can use Pythagorean theorem. However, the majority of questions you get with this sort of thing is going to be Pythagorean triples, which means it's like a whole number. And so this is 24. You can get like a list of those pretty easily somewhere. So they'll say like 3, 4, 5, and then there's like the 5, 12, 13, and so forth. This one here is 7, 24, 25. Next thing I want to do is look up a formula like an identity. I don't want to close this window right now because I'm gonna have to redo everything. But the identity here is sine to theta, and that is always going to be equal to 2. Okay, so right here you have sine and cosine. It's usually written the other way around, but it doesn't matter. So sine and cosine. To find these identities, you do just a Google search of you say trig identities. These in particular are the double angle identities, but like if you just do trig identity sheet and on the search options, you want to go for large. In other words, something you could like print out that'll show you everything. But if you just want to look up the particular ones really quick, these are called the double angle identities. So how to use this. So I'm going to use this here because this is what it's asking for. It's asking for sine 2 theta. So sine 2 theta equals 2 times. I'm gonna keep it the same order as you have it over here. So let me switch these two. So cosine of theta would be. Well, we go look at the picture here. First of all, I label this as negative here. This is also negative over here. So that is going to be the adjacent to the angle, which is -24. over 25, which is the hypotenuse. So if you label your positives and negatives correctly, you're going to get the right sign. Otherwise, you could just think about this stuff. All right, so tangent and cotangent are the only positive ones there. So cosine's got to be negative. Then we have the sine of this. We're given that. That says negative 7 over 25, but you can look at the picture too. Okay, opposite's negative 7. Hypotenuse is 25. So what this is setting up pictures using a proper identity and then plugging in with the solid knowledge of trig here. So I'm going to simplify all this here. 25 times 25, that's 625. 48 times 7. Okay, that looks right. 26. And it's positive. Okay, so that one's done. All right, so B, we have cosine 2 theta. So we start with the picture first. I would do pictures for all these to get used to it. I mean, I still use pictures when I'm trying to figure out these things. It's the same information, isn't it? Okay, so I don't even need this. It's the same picture. So this next one is cosine 2 theta. Now this actually has a few different identities you could use. So if you look up cosine 2 theta, it's going to give you a few to work with. And the way you choose which one you work with, you see like what you have and like what's going to be the easiest. This one has a cosine and sine. All right, so we're going to use that. Remember that if you have a square here, it really means cosine theta with the squared on the outside, just short form. Okay, so we're going to take the cosine, which we found before, and we're going to square that. And then this one is the sine, square root of that. Okay, so we're squaring negative numbers, becomes positive. This all looks good, these values. Minus, okay, so that's going to be positive, 625. Same denominator, so we just subtract those. Okay, 520. Yeah, okay, we're good. That's it. And the last one we have is the tangent. So this is actually, this just example is pretty good because it's covering all three things. The tangent to theta. I, for the life of me, can never remember what the identity is, but it looks like you have it there, which is this guy. Again, you get these from a reference sheet, either given by your teacher or just find it online pretty easily. Just kind of quick check to see if this is the right one. Yeah. Sorry for the delay. I'm just making super sure that everything's right here. All right, so two and then tangent. We didn't do tangent yet, so we go back to this one right here. So it's opposite over adjacent. So that's -7 over -24. I'm just gonna put 7 over 24 because the negatives cancel out. And the bottom we have that same number, and then we're squaring that. Now this one takes a little while to work out because of diffraction. Okay, so the top, remember this is like 2/1. So it's 14/24. Let me leave it like that for now. We'll reduce later. Some people like to do these in less steps, which you could do as long as you're really careful. That is 576. All right, so what I'm going to do is come up with the common denominator for the bottom and simplify the top. I was just looking at this work here. I would have made that into a 7/12, but I see like that the cancellation works well, so maybe I'll just leave it. So this is 14/24, and then you know this stuff here. So I'm changing 1 into 576/576, and then subtracting 49/576. And so that's what's going on there. Let's get rid of that question space. Okay. 527. Notice that's the same number from before. This is the same subtraction. And then we're just going to rearrange this. So smooth here. And to keep, change, flip. It's 576 is 24 squared. Okay, so that cancels out nicely here. This leaves us with 24. Then you just have to multiply across the top. Okay, that looks right. 336 over 7. All right, and that's it. Okay, so just quick review what happened here. These are all, we started with all the same information, drew a careful picture with the unit circle about where it was. So that's why we get our signs, positives and negatives, correct? And then we use identities to solve all three. The double angle identity for sine is really just the one equation. For cosine, there's like a few of them, and for tangent, there's one of them. All right, so I'll end this video here and do the other thing later.